Hello, my name's Jeshan, and today I'll be doing a short video into a lesson or part of a lesson that I would be teaching. So today we'll be going through types of chemical bonds or chemical bonding in general. Now, it's important to understand that chemical bonding is a very important topic in chemistry because it's all around us, and you'll see after we do an example or two that it's very applicable to the real world. So let's just get started straight away and go through the three types of chemical bonding there are. We'll be going through one of them in a little bit more detail, and the other two I'm just going to give you a slight outline into how they occur and when they occur, just so you can spot a few key differences between the types of chemical bonding. So the first type is ionic bonding. Now it's important to understand here that ionic bonding occurs between metals and non-metals only. So occurs between metals and non-metals only. And the way that this occurs is through a transfer of electrons. So there is a transfer electrons. So the metal will donate one or more of its electrons from its outer shell to the non-metal. And the reason it does this, and as you'll see, the main aim of the different types of bonding is to achieve a full outer shell, just like group 8 does, where it has 8 electrons in its outer shell. So the metal donates one or more electrons to the non-metal. So that's how ionic bonding occurs. Covalent bonding is the next one. Covalent bonding. Now, covalent bonding occurs between non-metals only. Occurs between non-metals only. That's important. It's only between non-metals, and there is no transfer of electrons. There's no donation of electrons. What happens is atoms come together and they will share their electrons, and that is what we call the covalent bond. So there is a sharing of electrons. Finally, we have metallic bonding. A key point to understand here is that metallic bonding occurs between the same elements. So let's take, for example, zinc. In metallic bonding, there will only be zinc atoms in the structure. So it occurs between the same elements. Or the same element, I should say, rather. And the way it does this is they form regular or uniform patterns, we can say, uniform structures. Okay, so there you have it. There's some key differences, as you can see here. Ionic bonding occurs between metals and non-metals only. However, in covalent bonding, it occurs between non-metals only. There are some similarities, you can say, between ionic bonding and metallic bonding. However, we'll go through them in another lesson because it will require a lot more time to understand. But today, let's just go through ionic bonding in a little bit more detail, and you can understand and see how it works. And the best way that we can do this is by doing an example. So let's take sodium. So sodium is in group 1 of the periodic table. So take sodium here. And we'll show the outer shell with, by the way, what we're going to do now, these are called dot and cross diagrams, and this is how we represent the different types of bonding. So this is sodium and the outer shell of sodium. From here, if you look at your periodic table, we have to deduce how many electrons there are in the outer shell of sodium. Now there's two ways we can do this. There's a simple way, but let's go through slightly more complex way, just so you can understand how we get to that, the thought process behind it. So sodium, if you look at the periodic table, has 11 electrons in its structure. Now we should know from previous knowledge that the first shell of all atoms can only hold 2 electrons. Following this, each subsequent shell can hold 8. So if the first one has 2, we have to fill another 9 electrons. So the next shell, the maximum it can hold is 8, therefore there will be 8 electrons in it. As a result, we can now say that we've filled 10 electrons. So if we fill 10 electrons and sodium has 11 electrons in its structure, we must now say that there is only 1 electron in the outer shell of sodium. So how we can represent this is with either a dot or a cross. So I will be doing sodium with a dot. Let's just get the pen. And so this is the electron in the outer shell of sodium. This is the 1 electron that we have here. Let's take chlorine now. Okay. Chlorine. So earlier I said there's 2 ways that you can deduce how many electrons there are in the outer shell. We went through with sodium one way, now there's a more simpler way we can do this. So sodium is in group 1, therefore we can say that there is 1 electron in its outer shell. Group 2 elements all have 2 electrons in its outer shell. So if we take chlorine, chlorine is in group 7, and therefore we can say that there are 7 electrons in the outer shell. So let's just write that down here so you can see 7 electrons. Now in order for sodium to gain a full outer shell, what it must do is donate one of its partially filled shells, which is with the 1, to another element. Now sodium is the metal, and it will donate one of its electrons to the chlorine. Now we represent the second element's electrons with crosses, and that's why we call these dot and cross diagrams. So sodium will need 7, as there is 7 electrons in its outer shell. So as you can see from this, chlorine would benefit from an extra electron, as instead of 7 it will then have 8 electrons, so it's achieved its goal of having a full electronic outer shell structure. So let's just show this by it donating its electrons. Now the result of this is sodium chloride here. Let's just make this 50. So sodium chloride. So it's bonded together, and now it is sodium chloride. Now sodium has donated one of its electrons, therefore it has a surplus of protons and a deficit of electrons, therefore it is positively charged. Chlorine, which is now chloride, has gained electrons, so now is negatively charged. So sodium chloride, the use of this is table salt. It's used on food, etc. And this is a slight introduction into ionic bonding. Thank you.